Here's question 26. It says triangle ABC has a perimeter of 10 and the lengths of its sides are all integers. Now remember, integers mean there's not going to be half parts. And since we're talking a triangle, you're not going to have any negative numbers here. But you're not going to have a side length of 2.5 or 3.1. It's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If A is the length of side BC, what is the difference between the largest and smallest possible values of that length BC? Now the first thing we need to remember is, let's say we have a triangle. And you say, oh, well, this side's 1, this side's 2. And remember, it has to add up to 10. So you say, oh, well, this side then has to be 7. That's not a possible triangle. There's no way I could have a triangle that's 1 inch on a side, 2 inches on a side, and then the third side ends up being 7, this long length. You should remember back to geometry that a third side has to be between the difference of these two numbers, that's subtraction, and the sum of these two numbers, add them together. So if I have a side of, let's say, in a triangle, somebody told me this was 6 and this was 4. I know this third side, I'd subtract them, has to be somewhere between 2 and add them 10. It has to be between 2 and 10. Can't equal 2, can't equal 10, but since it's 6 and 4, I look at the difference of them and the sum of them, and that third side must be between them. Hopefully you remember that from geometry, because that plays a part in this problem. If you and I go ahead and start with this triangle now, and let's say here is BC, and I try to make this side 1. Well, I'm going to see that that's going to be very difficult to do because it has to add up to 10. So if I have a 1 there, let's say this is a 3. 1 and 3 would make 4, so this has to be a 6. Because again, the perimeter, the distance around it said had to be 10. That would be 10, but notice 6 minus 3 is 3, add him 9. He's not between it. Well, what if you change this to a 4? 1 and 4, that would then make this 5, but then again, you subtract them is 1, you add them 9, but this side isn't between 1 and 9, it's exactly equal to 1. So you're going to see that this triangle can't be made with the side being equal to 1. It's just not possible. When we start exploring what it could be, well, let's see. Here's B, here's C. Let's make it a 2. 2 is possible, and if I have a 3 here, that would have to be a 5, wouldn't work. But what if you had a 4? If I have a 4, 2, 4, that adds up to 10. 4 minus 4 is 0, add them 8. 2 is between 0 and 8. We have an isosceles triangle here. That's possible. 2 is the smallest possible value we can make for A. Now the question is, what's going to be the largest possible value we can make for A? Well, if we try to do 5, we get into that same problem again. What are you going to do? 5, you can't do 3 and 2. You can't do 4 and 1. You can't do, you're in that same problem again. What's going to happen? You could do a 3, but notice just even back here, we could just make that side 4, and then maybe this 4 and that a 2. So we can notice with the numbers that what's going to happen is the smallest we can make that side BC is 2. The largest we can make it's 4. So the difference between the largest and smallest possible values of A, well, 4 minus 2 is 2. The answer to that problem is 2. A little tricky. You got to remember some of your geometry bits. A lot of kids make the mistake of making it 1 and then an 8 or something, say the difference is 7. No, because that wouldn't be a possible triangle. So there's the answer to 26. The answer is 2.